Hello, it's Dumplet here. Welcome to part 22 of 25 of the College Entrance Test Review. Credits to the Review Masters for providing me with these items. To continue, item 85. What is the remainder when 2x to the fourth minus x cubed plus 3x minus 1 is divided by x plus 2? Now in algebra, the remainder theorem tells us that if you want to get the remainder when a polynomial here, so the 2x to the fourth minus x cubed plus 3x minus 1, when it's divided by a linear factor, so only with a term of x, so x plus 2 in this case, we only have to substitute the value of x when this thing, or the divisor, in this case x plus 2, is equal to 0. So the remainder is simply, so we solve x plus 2 equals 0 first, so we're going to get that x equals negative 2. So x equals negative 2. So all I have to do, I'm going to substitute negative 2 back to the given polynomial. So I'll substitute negative 2 to 2x to the fourth minus x cubed plus 3x minus 1. And then all I have to do is just expand this and I'll be able to get the answer. So let's try to do that. Negative 2 raised to the fourth power, that's equal to 16. So 2 times 16 minus negative 2 cubed, that's equal to negative 8, so minus negative 8. 3 times negative 2, that's equal to negative 6, and minus 1 here. So 2 times 16, that's 32. We're adding 8. We're subtracting 6, and then we're subtracting 1. 32 plus 8, that's 40, minus 7, that's 33. So for item 85, it's 33, and it corresponds to choice D. So remember this trick, it's called the remainder theorem. So we just simply let the divisor, in this case x plus 2, just make it equal to 0 and then substitute the value of whatever you get for x. Item 86. If x equals y plus 4 and x equals 20 minus y, then what is the value of x squared minus y squared? Now it's very obvious enough already. Well, x squared minus y squared, it appeared in one of the previous parts. So we know the trick that x squared minus y squared can be factored, and because it's a difference of two squares. Now we can rewrite the blue and the green equations. So the blue equation from x equals y plus 4, I can write it as x minus y equals 4. And then for the green one, I can write x plus y equals 20. So how convenient is that? I already have the difference, x minus y, and I have the sum, x plus y. And I know that x squared plus y squared is simply equal to x minus y times x plus y. So that's direct substitution. So x minus y, that's equal to 4. X plus y, that's equal to 20. So I'm just simply getting 4 times 20, and that equals 80. And 80 here corresponds to choice B. So there we go. Item 87. The sum of the squares of two numbers is 225, and the square of their sum is 441. What is the reciprocal of their product? Now, the reciprocal of their product. So I've translated these three. So the sum of two. So let the two numbers be a and b. Now the sum of the squares, so a squared and b squared, we're going to add them. So a squared plus b squared is given to be 225. Next, the square of their sum. Now their sum is a plus b. So I'm taking the square of their sum. So the square of their sum is 441, and I'm asked for the reciprocal of their product. So their product is AB. So taking the reciprocal, so 1 over AB. Now, we can easily do trial and error, and trial and error is going to give you A equals 9, and then B equals 12. Or you can obviously switch to A and B. A equals 12, and then B equals 9. That also works. And if you want to get 1 over AB, that's simply 1 over 9 times 12. And that's equal to 1 over 108, and that's possible. That's a way to do it. But there's another way to do it, and you don't need to get A and B. But then again, trial and error is a very nice technique. So if you can do trial and error, then that's nice. Now, how do we deal with this? Take a look at this. A plus B quantity squared. We can obviously expand that, so we'll be able to see something after we expand it. So I'll write A plus B quantity squared as A squared, as usual, plus 2AB plus b squared, and that's equal to 441 as per the given. Now it's very funny because a squared plus b squared here exists, So it's going to be 225. And then the thing that we want, which is AB. Because if we know AB, we can get 1 over AB. So a squared plus b squared, that's equal to 225. So 225 plus 2ab, that's equal to 441. Now we can try to solve for, we can try to solve for AB here. So 225 plus 2ab equals 441. So subtract 225 on both sides first. So we're going to get that 2ab equal to 441 minus 225. That's equal to 216. And then divide both sides by 2. We're going to get that AB equals 108. So to get 1 over AB, that's simply equal to 1 over AB, so 108. So 1 over 108, and in both ways, you can get that the answer is choice B over here. So 1 over 108. I think the A here is just a typo, so we have choice B. So it's 1 over 108. Now for the last one, if logarithm of x with base 10 plus the logarithm of 8 with base 10 equals logarithm of 16 with base 10, then x is equal to, now here in logarithms, take note of the property. If I have logarithm of a with base x plus logarithm of b with base x, we can combine them into one logarithm. Just take the product here of a and b. So it's going to be equal to logarithm of ab, their product, base x. So I have two numbers here, x and 8. And then I'm adding technically, so I'm adding these two. So I can write it as one logarithm. So logarithm of x times 8, so I'll just write 8x. So it's equal to logarithm of 8x with base 10 is equal to logarithm of 16 with base 10. So just copy the right-hand side. Now they both have the same base of 10, so we can equate whatever is inside here. So it's going to be 8x. So 8x equals 16, so it's just a matter of solving for x now. Divide both sides by 8. X would equal 16 over 8, and that's equal to 2. So it will correspond to choice A. So just properties of logarithms for this item. Hopefully you guys learned something new from this video, and I'll see you in the next one. See you in part 23. Bye-bye!